In this video, we're given two equations, f of x and g of x, and we're asked to compose f with itself and g with itself. This is actually a continuation of the video I did in this problem a few minutes ago, but because I like to hear my voice and love to make videos, I just decided to make a second one. So let me do the first problem in the way that your teacher is probably going to want you to write it on your homework and on your test, and that's f of x. And then, because I don't have a number to plug into x, all I really can do is make a substitution where I take f of x and substitute it with what it's defined to be. So in this case, f of x was defined to be x squared plus x. So where I see f of x, I'm going to replace it with x squared plus x. So I do that. Now what I need to do is notice that this whole thing is now my input into f. In function notation in general, it's always f of input equals output. So in both these notations down here, they're screaming at you that f of x is the input here. Unfortunately, it's in the input into itself, but this means that x squared plus x is my input to f. So what I can do is, like I did in some other problems, is I can copy the original equation down, just leaving a bunch of blank spots. The original equation is f of blank equals blank squared. So wherever I see the letter x, I'm just going to put a blank. When you get good at this, you don't really do it this way, but it helps to do it this way now. And then plus 1 times x. I don't need to write the 1, I'm just going to write x. So I basically have f of x equals x squared plus x, but instead of having x's, I have blanks. It just seems easier to view it this way. And then if I want to find out what f of x squared plus x is, I simply just replace or write in x squared plus x in all the blanks, and then I simplify. So this is probably how your professor will want you to write your answer. And then I need to simplify this down. So simplifying, I have the left-hand side is f of x squared plus x. The right-hand side, since I have this binomial squared, it really means to multiply it by itself. This is going to come out a little more rigorous than I thought, but not a big deal. And then these parentheses really aren't necessary. Since there's a positive 1 out here, distributing a 1 does not change anything inside the parentheses. So let me just work on this right-hand side now. I'm going to have x squared times x squared, which is x to the 4th. I added the exponents, mind you. Then you'd have x squared times x, which is x cubed. You'd have another x cubed when you take this x and multiply by x squared. Don't forget the last terms, which is x times x, which gives you x squared. And then don't forget that you had all this over here, so plus x squared plus x. I'm going to copy the left-hand side down later on. So combining like terms, I have x to the 4th. I have x cubed plus x cubed, that's 2x cubes. I have x squared plus x squared, that simplifies down to be 2x squared. And then I have a plus x here. My left-hand side is f of x squared plus x. Or I could have written that this is equal to f of x, however your teacher wants you to write it. The best way probably is just to take the original question, f of x, and state what it's equal to. And if you were my student, this is what I would want on your homework or on a test as your final answer. Now this isn't probably how your teacher would like me to explain it or even for you to write it, but it just seems almost easier to understand, at least, if you just do it this way, where you copy f of x down twice, like this, and I do this only so I have something to point at. Now in this example it's a little confusing because the question f of x basically says to plug f of x into itself. So I basically have to figure out what f of x is equal to. What is f of x equal to? It's equal to x squared plus x. And in this notation says that it needs to be plugged into the function f, which is basically itself. Remember, the notation for functions is always f of input equals output. So they're really saying that f of x is my input, and we're plugging into this function that just happens to be f again. So where do you plug things into f at? Well, the input variable. So this is where I plug numbers into f, and this is where I plug numbers in. So what I have to do basically is take x squared plus x, which is the function f of x, and put it into itself. So wherever I see the letter x, I'm going to replace all of that with x squared plus x. So instead of x squared, I'm going to have all of this stuff squared. So that would be x squared plus x, and all of that's being squared. So basically I substituted this in to the first x value, x squared plus x squared, plus, but I haven't substituted this into this x yet. So we're just adding x, but remember we're substituting x with all this junk. So you have x squared plus x. And once in a while it's okay to refer to stuff as junk, just as long as your teacher doesn't hear you. Now I would have to simplify this out. I don't feel like doing that because I've already done it down here. Let me clear the board and I'll do g of x as well. So g of x means I'm not going to use the function f of x at all. So I'm not even going to copy it down. What I'm going to do is I'm going to copy the function g of x twice and pretend I'm just plugging it into itself. So g of x is x minus 3. I don't know why I said pretending. I'm not going to pretend at all. I'm actually going to do it. G of x is x minus 3. I'm going to write that down twice. And basically this notation says please take g of x and plug it in to the function g. So I take g of x, this is the equation. It needs to be plugged into itself basically. You have to locate where the input variable is. So if I asked you to plug a number into g, you'd put it right here. So basically this is where things get plugged into. What is it that I'm plugging in? Well, I'm plugging in x minus 3. So if you did that, if you wrote this equation out, x minus 3, but instead of writing x minus 3, imagine I just put x here for now. Instead, forget the x, plug in x minus 3 instead. This one would be very easy to simplify. So I have x minus 3 and then subtract 3 again. Of course, that's nothing more than x subtract 3 twice. And on a good day, when you subtract 3 twice, you get subtract 6.